Imagine a virus that can hide in your brain for years, long after you think you've recovered, only to wake up and attack all over again. Well, that virus is real. It's called Nipah, and it's one of the most serious emerging threats on the entire planet. Today, we're going to break down exactly what makes Nipah so dangerous.
Right off the bat, this tells you how seriously the world is taking this. When the World Health Organization, the WHO, puts a disease on its priority list, that's a global alarm bell. It means they see the potential for a major public health crisis. It puts Nipah in the same scary category as diseases like Ebola and Zika. It's basically a signal to the world's scientists that we're in a race against time.
And this is the number that keeps public health experts up at night, a case fatality rate between 40 and 75%. Just let that sink in. In some outbreaks, 3 out of every 4 people who get infected die. To put that in perspective, the fatality rate for early COVID-19 was hovering around 1 to 3%. This isn't just a number, it's a chilling measure of just how lethal this virus is.
So yeah, that's the big question we're tackling. Where does it even come from? How does it do so much damage to the human body? And maybe most importantly, what can we do to stop it? The answers are, well, they're complex, they're fascinating, and they are critically important for all of us to understand.
To be crystal clear, scientists can't just study this virus in any old lab. Nope, Nipah is a biosafety level 4 agent. That is the absolute highest level of biocontainment there is. It's in an exclusive club with other notorious killers like Ebola. It means the only people who can handle it have to work in labs that look like they're straight out of a science fiction movie, wearing these full-body, air-supplied spacesuits. Why? Because it's just that dangerous, and we have no vaccine and no cure if something goes wrong.
To really get a handle on the threat today, you gotta look at its history. The world's first brutal introduction to Nipah was back in 1998. It just seemed to pop up out of nowhere in Malaysia, causing this mysterious, terrifying brain inflammation in pig farmers. That first outbreak was huge. It caused massive panic, and over 1 million pigs had to be culled to stop it. But then, the virus kind of changed its strategy. By 2001, it had moved over to Bangladesh and India, and instead of these big explosive outbreaks, it settled into a more sinister pattern. Smaller, but recurring, almost yearly outbreaks. It showed just how persistent and dangerously adaptable it really is.
So, how does this jump from animals to people even happen? You know, understanding Nipah's journey is like being a biological detective. It follows a classic path for what we call a zoonotic virus. But the specific chain of events for Nipah is a pretty worrying example of how our interactions with the environment can basically open a door for a deadly pathogen to just walk right in.
And this is where it all starts. The fruit bat, sometimes called a flying fox. Now, here's a weird quirk of biology. These bats carry the virus, but they don't get sick from it. They're its natural home, its reservoir. The real danger isn't the bat itself, it's what the bat leaves behind. The virus is in its urine, its saliva, essentially painting the environment below with an invisible threat.
This slide really breaks down how that contamination turns into an actual infection. So it starts with step 1. The bats, the reservoir, are just doing their thing, shedding the virus. Step 2 is the vehicle that brings the virus to us. In that first outbreak in Malaysia, the vehicle was pigs. They acted as what's called an amplifying host. They got sick and produced huge amounts of the virus, making them super efficient spreaders. But in Bangladesh, the vehicle is often food, specifically raw date palm sap, a local delicacy that bats just happen to love. And that all leads to step 3. The virus finally reaches people.
So let's look a little closer at these pathways. The food route is a big one in places like Bangladesh, where people might drink fresh sap that a bat contaminated just hours earlier. The animal contact route, well, that's what drove that massive Malaysian outbreak. But it's this third route that really has global health authorities on edge: human-to-human transmission. Close contact with an infected person's respiratory droplets can spread the virus. This is why caregivers and family members are at such high risk, and it's this exact capability that gives Nipah its scary pandemic potential.
All right, so once the virus makes that jump into a person, what does it actually do? This is where Nipah shows its truly devastating side. It's an assault that can target both your lungs and, most terrifyingly, your brain and central nervous system.
Looking at this timeline, you can see just how sneaky this disease is. It all starts with the incubation stage. Up to 2 weeks where you're infected, you might even be contagious, but you feel totally fine. Then comes what's called the prodromal stage. It's a fancy term for when you get those early vague symptoms: fever, headache, vomiting. Basically, it feels just like the flu.
But this is where it takes a really dark turn. The encephalitic stage can follow, a direct attack on the brain that causes confusion, seizures, and a coma with frightening speed. And as you can see, even for those who survive, it's not over. The final stage can last for months or even years.
The biggest danger with Nipah early on is just how ordinary it seems. Fever, headache, muscle pain, it could be a dozen different things, and that makes it a huge challenge for doctors trying to get an outbreak under control. But behind that mask of a simple flu, the virus is getting ready for its real attack, which can escalate really quickly into severe trouble breathing or the hallmark neurological signs as it attacks the brain.
I really can't overstate this point. The sheer speed of the neurological attack is one of Nipah's most terrifying features. A person can go from seeming a little confused and drowsy to being in a deep coma in a single day. That rapid decline leaves such a tragically small window for doctors to do anything, and it often just overwhelms the local hospitals.
And this brings us to one of Nipah's most insidious secrets. Even if you survive the initial infection, you might not be free. This quote from a major study reveals that Nipah can hide. It can stay in the body, specifically in places like the brain where the immune system has a hard time reaching, long after the illness seems to have passed.
So this ability to hide, it has absolutely devastating consequences. The virus can lie dormant for months, or in some cases years, only to suddenly reemerge and cause a fatal relapse. For other survivors, the damage is permanent, leading to persistent convulsions, major memory loss, or profound personality changes. It's a terrifying reality. The battle against Nipah doesn't always end, even if you survive the first round.
So if there's no cure and no vaccine, how in the world do we fight back? Well, this is where public health, community action, and just our own behavior become the most powerful weapons we have. The fight against Nipah is really all about breaking that chain of transmission before it can even get started.
This slide lays it out in really stark terms. On the treatment side, our hands are pretty much tied. Care is what we call supportive, just managing the symptoms, trying to keep the person hydrated and breathing in an ICU, and basically hoping their own immune system can win the fight. But on the prevention side, we have a whole toolbox of strategies. And that's why all outbreak management is laser-focused on prevention. It is, right now, our only reliable game plan.
So what does prevention at the source actually look like? Well, a lot of the time, it's surprisingly simple, low-tech stuff that's just brilliantly effective. In Bangladesh, health officials teach people to use these bamboo covers called sap skirts to put over the pots collecting date palm sap. It physically blocks the bats. On farms, it's about basic security, covering animal feed and not building pigsties right under fruit trees where bats like to hang out. And simple food safety, like washing fruit and boiling fresh sap, can literally be a lifesaver.
On a personal level, the advice is really clear. It's all about awareness and hygiene. Stay away from sick animals and avoid places where bats are known to roost. You know, good old-fashioned hand washing is always a great defense. And most importantly, during an outbreak, avoiding unprotected contact with anyone who's infected is absolutely critical to stop the virus from spreading person to person.
And this all leads to a really crucial concept in fighting diseases today: One Health. The idea is simple but revolutionary. You can't separate human health, animal health, and the health of the environment. They are totally intertwined. Nipah is the perfect example. You can't stop the virus in people without managing it in animals and understanding the bat ecology that brings it to us in the first place. It's a holistic approach that's essential for preventing the next big one.
Now, while prevention is our best tool today, it's not our only hope for the future. Around the world, researchers are working like crazy to develop the vaccines and treatments that could one day neutralize the threat of Nipah for good.
And the good news is, there's real progress being made. On the treatment side, a leading candidate is something called monoclonal antibodies. Think of them as lab-made guided missiles that are designed to target the virus. One has already been used on a compassionate use basis for some patients. The antiviral drug remdesivir has also shown some promise in animal studies. And of course, the Holy Grail. Several vaccine candidates are in development. None of these are ready just yet, but they represent real, tangible hope.
This kind of leaves us with a critical thought, doesn't it? Nipah is like a lethal preview of our shared vulnerability to these emerging diseases. While we wait for the scientists to deliver a cure in a vial, we have to ask ourselves, what's our best defense right now? For a threat that doesn't care about borders, the answer probably isn't a single drug. It's collaboration. It's sharing data, funding research together, and strengthening healthcare everywhere. In a world as connected as ours, maybe global cooperation isn't just a nice idea. Maybe it's the most powerful vaccine we have.